My name is James Berzuk, and I'm a computer science undergraduate student. I've been working on a summer research project with Dr. James Young at the HRI lab, University of Manitoba, Canada. I have a background in linguistics and was interested about how humans and robots communicate. So we started by investigating the field and started to notice some patterns, such as the prevalence of a lot of command and response style interactions. We were interested in these patterns, but we weren't sure, so we decided to do a formal survey to find out more. We wanted to find out what systems in the field are actually doing. So we collected 75 papers from major venues and contacted the authors where necessary for more information. Thank you to everyone who assisted us in this process. With so many systems collected, we found it difficult to organize and compare them, and wanted a better way to describe the commonalities, so we formalized the patterns into a descriptive framework. And then to illustrate the application of that framework, we selected systems from our survey to use as case studies to demonstrate the framework's use with real systems. Altogether, we offer a way to understand and compare systems, as well as an overview of work in the field. We developed the framework based on the survey in order to provide a vocabulary to understand and compare disparate systems. The dimensions of the framework divide into two sections, design and implementation. And within design, we have discourse genres, interlocutor composition, and dialog structure. In addition to enabling the understanding of existing systems, these dimensions offer an anchor for consideration when designing new ones. So the first dimension is discourse genres, which is a tool inspired by work in linguistics and is used to classify the interaction according to its basic function. In our survey, we found 4 basic functions. Commanding, the issuing of commands or offering of instructions. Questioning, asking questions and receiving answers in a back and forth format. Informing, supplying information in a more unilateral way. And entertaining, where one party is providing entertainment to the other. Note that each of these actions can be performed in either direction, by the robot to the human or vice versa. And also that one system may incorporate multiple genres at different points in its interaction. Discourse genres provide a means of understanding and comparing the goals and purposes between systems. Now the next is interlocutor composition, which is similar to the HR ratios you may be familiar with, but we've generalized the numbers into one, a few, and a crowd. For example, an interaction may be one robot to one human, one robot to a human crowd, or a few robots to a few humans. These groupings highlight key distinctions in the designs. For example, when interacting with a few, there may still be a possibility for one-to-one interaction, whereas this is less feasible with a large crowd. The last design aspect is dialog structure, which describes the high-level flow of the interaction. For example, you might have a linear interaction that's pre-scripted and follows a set path, even if it has short deviations or loops. Or you may have a branching interaction that, while also scripted, is more responsive to user input and has potential for deeper and more permanent deviations. In contrast to these, some interactions are unstructured. They don't really have a clear flow, instead they're made up of isolated utterances, and they're more reactive to their immediate circumstances. These dialog structures describe sort of the flexibility and structural complexity of an interaction. Now, we don't have enough time to get into everything, but we did the same level of analysis when considering implementation details that impact dialogue, and we found 3 more dimensions. Whether the system operates independently of a human operator, the range of modalities that are employed in the interaction, and select algorithmic techniques that were relevant to the dialogue. More details about all of these dimensions are available in the paper. Altogether, the framework allows for the understanding and comparison of disparate systems, as well as offers a lens to consider new designs. And as an added benefit of the survey, by applying our framework to the 75 systems we collected, we've produced an overview of what kind of systems are in the field. We displayed the results of this in a diagram in the paper, but I'll highlight a few interesting results here. Some results are unsurprising, the vast majority of systems being one robot to one human, for example. In comparison, robot crowds were completely unattested, which might be expected given the cost. We found that over half of systems were fully autonomous, which demonstrates a substantial effort being made toward developing practical systems. But some results were more unexpected. For example, that the robot-to-human discourse genres were much more common than the human-to-robot equivalents. This is intuitive in some cases. It does seem more plausible for a robot to be entertaining a human than the reverse. But it is striking that we found twice as many cases of robots commanding or questioning people as we did of the reverse. And we also include further data in the appendices in order to support future analysis, including the full classification of all 75 systems, and a table of frequencies of each combination of the features in the framework. So I've introduced the framework, and I've described how it can be used to understand dialogue interactions. But I'd like to demonstrate how it applies to real systems. So we've selected a few very different interactions from our survey, and I'm going to present them as case studies. So, for example, Morimoto et al. Developed a robot for receiving and addressing customer complaints. And I will describe this using the framework. The system involved one robot addressing one human, and it followed a linear structure. First listening to, and then responding to the complaint. The system went through 3 discourse genres. The customer informs the robot of the complaint, the robot questions the customer for more information, and the robot informs the customer of the company's response. The system had a Wizard of Oz operator. Both parties used voice, and the robot generated its using speech synthesis. So in this way, the framework provides a concise vocabulary to summarize the robot. For another example, Vilken Fitter developed a robot that delivers a stand-up comedy routine. And I'll again describe this using the framework. It delivers a solo routine in front of a human crowd, follows a mostly linear script, autonomously, and uses synthesized voice and motions to entertain the audience. The audience in return had limited ability to communicate back, using non-speech sounds, like cheers and applause, which the robot analyzes for volume to adjust its delivery. As a final example, Mizumoto et al. Developed a security guard robot that tries to correct the behavior of passerbys. It tries to stop them from using the phone while they're walking. So in the language of the framework, the one robot approached lone pedestrians, and in comparison to previous interactions, this one was more unstructured, involved isolated utterances to each individual rather than a broader conversation. The robot commanded the pedestrians using synthesized voice as well as its motion to make itself more convincing. And it required a human operator, but its dialogue delivery itself was autonomous, so we classify it as a mixed implementation. Now, in addition to providing the vocabulary to describe the systems, our framework offers insight into the nature of the interactions. For example, with Morimoto et al.'s customer service robot, framework in this way emphasizes the bidirectional nature. It featured both robot-to-human and human-to-robot discourse genres, which demonstrates that the robot guides the interaction, but both parties are active participants. In comparison with Vilken Fitter's comedian robot, the discourse genres and the modalities show that the interaction is dominated by the robot. And further, with Mizumoto et al.'s security guard robot, it had no human-to-robot modalities whatsoever, which demonstrates a completely unilateral interaction. This is one way that our framework highlights a key distinction between the systems. So in conclusion, our survey offers a wide overview of the types of systems in the field. The framework offers a vocabulary and lens to examine new and existing designs, and our case studies demonstrate application to real-world systems. We hope this will prove useful in informing future robot dialogue designs. Thank you for listening.